Welcome back to the deep dive. When it comes to these huge, overarching scientific theories, maybe the hardest part isn't just coming up with the idea,
Mm.
it's figuring out how you prove it's actually true, right? Especially when you're talking about something that tries to link, I don't know, the tiniest particles with like the entire universe.
Absolutely. How do you even define the rules for accepting such a massive claim?
Exactly. And that's what our source material tackles today. It's a very technical, very formal document, pretty recent too. It lays out the bedrock criteria for what's called the postmodern unified theory, or UPT.
Mm-hmm.
Specifically, we're diving into the Buntun Sentet Ongchun UPT that translates to the four criteria for cotransference truth, put forward by Lei Than Hao.
Right. And our mission really is to decode this for you. Think of this document as, I don't know, the UPT Constitution. It sets out precisely 4 steps. They call them an axiom, a law, a theorem, and an application rule. These are meant to be the absolute standards of truth for the theory's core idea, this concept they call cotransference.
Cotransference. All right, let's get into it. So before we hit the law or the theorem, what's the absolute foundation? What's the first thing we need to grasp?
Well, it starts with the fundamental unit itself, the founding. It's labeled F in the math.
The founding.
Yeah, in UPT, the founding is, let's say, the entity that drives the system's inherent motion. It could be a particle, maybe a localized field. But for these criteria, it's the source of this stable intrinsic movement.
Got it. So criterion I.
Criterion I is the founding ownership domain axiom. This is about setting the initial absolutely stable conditions. Every founding F has to exist inside a defined ownership domain.
A domain, like a physical space.
Exactly. A specific region in 2D or 3D space with clearly defined measurable boundaries.
And the source mentions specific boundary types, Dirichlet and Moomin. What's the idea there?
In simple terms, yeah, they define the founding sphere of influence. Dirichlet boundaries are where things are fixed, like held in place.
Okay.
Newman boundaries are where stuff like energy or flux can cross the edge. The axiom basically says, this founding needs a clear, unambiguous sandbox to exist in.
Right, that defines the physical space. But the axiom also brings in some pretty abstract math concepts, these projections. They seem crucial.
Oh, they're absolutely key to the whole stability idea. The axiom demands you define 2 things, a cutting projection and a non-cutting projection.
Cutting and non-cutting.
You can sort of think of the non-cutting part as representing the smooth, stable, predictable motion, the kind of movement that keeps the founding intact, structurally sound.
Okay, so that's the good motion in a way.
Right. And the cutting projection, conversely, is the math that measures disruption. Things like localized breaks, energy loss that isn't conserved, deformation, basically things that mess with the founding's integrity.
And the whole point of UPT then is that cotransference happens when you get rid of that cutting component.
That's the core idea, yes. You need to neutralize the cutting component to achieve fundamental stability or cotransference.
Now, this part is fascinating. Configuration invariance. It seems to say that this definition of cutting versus non-cutting can't just change because the system wobbles a bit.
Precisely. The axiom defines a whole class of valid ways the configuration can change movements or transformations the founding is allowed to undergo.
Okay.
And then it slaps on a strict mathematical limit. It says if the founding go through one of these valid changes, the difference in how those cutting and non-cutting projections behave must be tiny, really small, bounded by specific error constants.
So the first standard is essentially an internal stability guarantee. No matter how the founding shifts configurationally within limits, the basic physics of what's stable, non-cutting, versus what's disruptive has to stay fundamentally the same, right?
Exactly right. It ensures the definition itself is robust. So you've set up your stable playground with axiom I, and you've got the mathematical tools to distinguish stable motion from disruptive motion.
Okay, playground defined. Now we get into the action with criterion percent, the cotransference law for the accretion system. If axiom I sets the stage, this law dictates what has to happen dynamically, doesn't it? What does the founding need to do?
It needs to hit what the document calls the critical UPT stopping condition.
Stopping condition.
This is where that cutting projection gets forced to 0. Mathematically, you look at the system's overall objective function, let's call it I, and how it changes. The law demands that the cutting projection's effect on that change must be absolutely 0, nullified.
Right, so you're actively forcing the system to eliminate its disruptive, its cutting aspects. But hang on. If you just mandate that away mathematically, aren't you potentially ignoring real physical processes like friction or heat loss or entropy, things that are inherently cutting or non-conservative?
Well, that's the bold claim UPT is making, isn't it?
Yeah.
The law basically says if you can meet that stopping condition, if the cutting part is successfully suppressed, then any motion that's left must come purely from an internal potential, something intrinsic to the fountain itself called I saw.
An intrinsic potential.
Yes, and the punchline of the law is this big declaration. When that happens, the state of the system, specifically its intrinsic gravitational attraction, is officially declared to be in cotransference with the fountain F.
Ah, okay.
So cotransference is achieved when the system sheds its disruptive elements and moves only under its own internal conservative steam, so to speak.
Which leads logically to criterion the third, the UPT cotransference theorem. This sounds like the proof, the engine connecting the law's dynamics back to the axioms definitions. It establishes why this state is both necessary and sufficient for cotransference.
Exactly. It formalizes the conditions. First, you need a basic assumption. The system's velocity, let's call it $5, has to be reasonably smooth, mathematically well-behaved over time. No sudden infinite jumps or anything crazy.
Minimum regularity, okay.
Then the theorem states, cotransference holds if and only if it's a two-way street. Two specific conditions are met.
Oh, wait, what's the first one?
Condition 1. The velocity dollars must belong entirely to the non-cutting space. Remember that space. It's defined as the kernel of the cutting projection.
Meaning anything moving within that space automatically has zero cutting component.
Precisely. So the actual motion has to be purely non-cutting, which lines up perfectly with what the law demanded by setting the cutting projection to 0.
Okay, the dynamics must be purely stable and conservative. What's condition number 2? This sounds like the trickier one.
Condition 2 requires that there must exist that generating potential we mentioned earlier.
The intrinsic one.
Yes, such that the velocity dollars is just its rate of change over time, its time derivative. And crucially, this potential dollar must generate a specific flow, a motion pattern. Let's call it Safety sub t.
Okay, why is that specific flow so important?
Because, and this is the kicker, that flow sub t absolutely must be one of the valid configuration changes allowed way back in Axiom Y. Remember the class Nath Calvin?
It connects all the way back.
Exactly. So the motion dollars has to come from a potential ACK, and the flow generated by that potential has to be one of the transformations that keeps the fountain configurationally invariant within those tiny error bounds defined at the very start.
Wow. Okay, so the theorem really closes the loop. It proves that this non-cutting, intrinsically generated motion is precisely the kind of stable, configurationally invariant motion defined in the axiom. It all locks together.
Beautifully, yes. A closed logical structure.
So we've got the rules, axiom, the required action law, and the logical proof theorem. Criterion the fourth, the application rule, sounds like the practical bit, the read the manual section. For a theory that claims to unify everything, what are the actual limits? Where can you apply this?
Right. This is the dose of practicality.
Yeah.
Criterion on the feet basically says, hold on, the law and theorem only work if your fountain system meets a checklist of specific conditions. It's about avoiding applying the theory to mathematically messy or ill-defined situations.
Makes sense. What kind of checks are we talking about?
Well, key geometric ones include the domain, being Lipschitz.
Lipschitz, meaning?
Essentially, the shape of the system's boundary has to be reasonably well-behaved. No crazy infinite spikes or fractal edges that make the math fall apart. It needs a sensible, measurable shape.
Okay, practical geometry. What else?
The boundaries, Dirichlet and Neumann, must be separate. They can't overlap, and they need to have positive measure.
Positive measure, meaning they have to be actual boundaries, not just single points.
Exactly. They need to be substantial enough to actually define the edges of the domain meaningfully. And then there are material conditions. The material tensor needs to be symmetric and positively bounded. Basically, the stuff the system is made of has to respond realistically.
Okay, so you need a well-defined space, sensible boundaries, realistic materials, and it also mentions practical verification steps, the keen trothy.
Absolutely. This is the checklist for anyone wanting to actually use or test the theory. The application rule says you must verify 3 things in your experiment or simulation. Which 1? Show that the cutting stopping condition is actually met, that power dollar I really equals 0. 2, check that the measured velocity dollars is indeed purely in the non-cutting space. And 3, you have to successfully construct or demonstrate the existence of that potential magia that generates the required stable invariant flow feat.
So you can't just assume cotransference, you have to actively demonstrate these mathematical components exist for your specific
You
system.
have to show you're working, yes. It's a rigorous standard.
Right, so pulling it all together. If a system satisfies all four criteria, the stable setup in the axiom, the dynamic requirement in the law, the logical proof in the theorem, and the practical conditions in the application rule, then the document concludes these serve as the standards of truth for saying that system exhibits cotransference within UPT.
That's the framework. And it leads right back to that staggering claim about the theory's scope. The source is quite explicit. UPT is proposed to be applicable from microstructure to the universe.
That scope is just immense, from the quantum scale maybe all the way up to cosmology. But doesn't that create a huge challenge? Maintaining those assumptions, especially the minimum regularity, the smooth, well-behaved motion across such vastly different physical regimes.
That's the crux of it, isn't it? The theoretical burden is enormous. Think about it. Classical systems might often be smooth, but what about quantum jumps, phase transitions, black hole singularities, general relativity near extreme gravity?
Yeah, those don't sound very smooth or non-cutting.
Exactly. Achieving that assumed regularity across scales, from quantum foam to galactic clusters, seems incredibly difficult. UPT seems to imply that physics has this deep underlying coherence, where all those apparent discontinuities are just localized cutting phenomena that can, in principle, be suppressed or filtered out by meeting the stopping condition.
It demands an almost philosophical belief in the fundamental predictability and conservativeness of the universe once you filter out the messy bits.
It really does. It puts the onus entirely on demonstrating that you can suppress the cutting elements, and that the flow which remains always conforms to that initial configurational invariance from the axiom. The mathematical rigor required is profound.
Well, thank you for walking us through the incredibly dense but fascinating framework those four criteria really build on each other.
They certainly provide a very specific definition of truth within this theory.
Okay, leaves us with something to think about. If UPT's core mechanism for achieving this fundamental state, cotransference, relies on eliminating the cutting component, the part that measures deformation, dissipation, non-conservative effects, how does a theory like that ultimately account for something as fundamental as the arrow of time itself? Processes like entropy increase seem intrinsically tied to those very cutting, irreversible dynamics that UPT aims to nullify. Where does that fit in?